Hello, you're welcome to my YouTube channel. In this video, we're going to solve these equations. Are you ready? Let's get started. So what we have here is log y base x plus log x base y is equal to 26 over 5. And then we have xy is equal to 64. What we can do here, this is log y base x, this is log x base y. Now, because I want it to be identical, the argument here to be the same and the base, I'm going to take the reciprocal of this. And that will mean me switching the position of the base and the argument. Let's see how that plays out. So I can rewrite this as what? As log y base x, then plus 1 over, because of the reciprocal, we have to now switch the position of the base. But x cannot be 0, because if x is 0, then this is going to be what? Undefined. You end up having 0 in the denominator. So I will have log y base x. Notice it has now changed from x base y to y base x, so it can match with this one. Then this is equal to 26 over 5. Now that we have log y base x here and log y base x, to make this a simple equation, I'm going to say let d, or let m, let's use m, let m be equal to log y base x. So I'll plug in m here. So I'll have m plus 1 over what? M is equal to 26 over 5. From here, I'm going to multiply through by m, because I want to remove this fraction from here. I don't want a fraction in this. Well, not just m, 5 and m, because the LCM of the denominator, 1m and 5 is 5m. So to clear up the fractions, I'm going to multiply by the LCM of 5 and m, which is what? 5m. So I'm going to have 5m multiplying m here, plus 5m multiplying 1 over m, all right? And then equal to what? 5m multiplying what? 26 over 5. All right. 5m times m is 5m squared. So this is 5m squared, then plus m cancels m, you have 5 here, and this is equal to what? 5 cancels 5, you have 26m. Next thing is to transpose 26m to the left-hand side. I'm going to have 5m squared minus 26m plus 5 is equal to 0. Now we have a quadratic equation. I'm going to multiply 5m squared and 5m. What's that going to be? 25m squared. So we'll think of two factors. When we multiply, we'll get 25m squared. But when we add, we'll get what? Negative 26m. What are they? Easy. Minus 25m and what? Minus m. If you add these two, you get negative 26. When you multiply this, you get 25m squared. So I'm going to wrap them in a bracket. So 5m squared, I'll replace negative 26m with this 2. So I'll have minus 25m minus m plus 5 is equal to 0. Now let me move this out of here and then rewrite this. So let's pick the first two terms. What's common here? 5m. So 5m bracket m minus what? 5. Because 5m goes into 25m, you get 5. What about this one? What's common here? It might look like nothing is common, but 1 is common. So that's minus 1. Minus 1 into minus m is m. All right? And then minus 1 into plus 5 is minus 5. All is equal to 0. Can you see that what we have in the bracket are the same? So we factor it out again. So m minus 5 in bracket, and then what? 5m minus 1 is equal to 0. What does this mean? It means that m minus 5 is equal to 0, or 5m minus 1 is equal to 0. So when you transpose this over, you have m is equal to 5 here, or m is equal to, move minus 1 to the right hand side, you have 1. Divide both sides by 5, you have this. So these are the two values of m that we have. But recall that what? Recall that m is equal to what? Log y base x. So let me change this to an initial equation. All right, so it's going to be like this. Let me just write this as log y base x is equal to m. So from here, I'm going to say when m is equal to 5, let's solve this. When m is equal to 5, I will have log y base x is equal to 5. But we have y, we have x. What do we do with those two variables? See, from equation 2, this is equation 1, this is equation 2. xy is equal to 64. So I'm going to say that since from equation 2, xy is equal to 64. To get an expression for y, I can decide to divide both sides by x. So y is equal to what? 64 over x. We now come here, we come to log y base x is equal to 5. So log y base x is equal to 5. Let's change this from this form to an indicial or to an exponential equation. If you do that, this base comes over to the other side. So you have y is equal to what? X raised to the power 5. But we also have that y is equal to what? 64 over x. So I'll replace y and put what? 64 over x, which is equal to what? X raised to the power 5. It's easy to get the value of x since all the variable we have is just x. Now let me take this off and we'll write it from here. So if I write over 1 and I cross multiply, I will have that x times, I will have x times x raised to the power 5, x times x raised to the power 5 is equal to 64. All right. Now, using the law of indices, we're going to add the exponent. So you have x raised to the power 1 plus 5, which is 6, is equal to 64. What do I do next? Take the sixth root of both sides to get rid of the power of 6 here. So the sixth root here and the sixth root here. This cancels this, and x is equal to the sixth root of 64 is 2. So that's 2. We've gotten one of the values of x. Now we also have that what? When m is equal to 1 over 5, so let's keep on writing. When m is equal to 1 over 5, let's get the value of x. So the same thing here, I'll just use this from here. So from here now, log y base x won't be equal to 5 anymore. It will be what? Equal to 1 over 5. So log y base x will be equal to, this was 5. When m was 5, we had it set to 5, m here. But now we are using what? 1 over 5, because m here is what? 1 over 5. So 1 over 5. Okay, when we change this to an exponential equation, you have x raised to the power what? Or let me just say y here is now equal to x raised to the power of 1 over 5. But again, we know that what? Y is equal to 64 over x. So replace y and put 64 over x. So 64 over x is equal to x raised to the power 1 over 5. When you cross multiply, all right, you're going to have x times x raised to the power 1 over 5 is equal to 64. Let me see if I can squeeze it in here. And that will be what? X times x raised to the power 1 over 5 is equal to 64. Now, there's a power of 1 here. If you add both powers, because using the law of indices, you are to add the powers. They have the same base. So you have x plus, or x1 whole number 1 over 5 is equal to 64. So what is 1 times 5? That's 5 plus 1 is 6. So x raised to the power 6 over 5 is equal to 64. Now the question is, how do we get x from here? We need to take the sixth root of both sides to cancel this power of 6 here. Let's do that first. So take the sixth root here and here. This sixth root will cancel this. So you have x raised to the power 1 over 5 is equal to, the sixth root of 64 is 2. But now, how do we get rid of that fifth root? Because that is the fifth root of x. You now apply the fifth power to both sides. So this 5 cancels this. You have x is equal to 2 raised to the power 5 is what? 32. Now we've gotten the two values of x, which are what? 2 and 32. What about y? It's easy. From equation 2, we have that x times y is equal to 64. So taking this off now. So again, from equation 2, we have xy is equal to 64. So I'll say when x is equal to 2, when x is equal to 2, let's get the value of y. So that would be 2 times y is equal to 64. Divide both sides by 2 here and then here. 2 cancels to y is equal to 64 divided by 2 is 32. Now, when x is equal to 32, the other value of x here, let's get the value of y. Again, 32 times y is equal to 64. Divide both sides by 32, you have that y is equal to 64 over 32 and y is equal to 2. So what we have is, together we have that what? When x is 2, what is y? When x is 2, y is what? 32. And when x is 32, What is y? Y is 2. So this is the solution to the equation. If you found this useful and helpful, kindly subscribe to this channel. And don't forget to like and share this video with your friends and family. Hope to see you in the next one. It's bye for now.